Hello students, welcome to the Yupp Master. Today we are going to take the interesting topic, that is motion in one dimension, which is very important topic for the entrance examinations also. So let's have a look. Rest and motion. If you are going to take that rest and motion, how you will confirm? Please take that. How you can decide that whether the body is in rest position or it is in motion? How it will confirm? How do you know? Yeah, it's very clear. If you are knowing the position of the object or any macroscopic body is changes with respect to the surroundings, and you can take that. Time is also one important parameter to decide whether its position changes with respect to the time it is in motion. Let's have a look. Rest position. We can take that some objects which are going to be permanent, they are going to be fixed at fixed position. Yeah. Unless until they are not going to be change their position. Unless until they are not going to change their position. When it happens, no, there exist a natural disasters, no, like earthquakes and some other cyclones, and they may destroy their positions. They are going to displace their positions. It's very clear. Otherwise, they are going to be at stable. They are going to be fixed. Their position doesn't changes. It's very clear. Now they are at rest position. They can't move. They are on the earth. Earth is moving, just we are going to observe that their position is fixed. Suppose if you are going to observe, if you are going to observe from the moon, you are going to take that. Yes, you have been observed from the moon. So these are all going to be in motion. They are appearing in motion. Now it is very clear, because earth, it is going to be earth. It is going to be on the earth. Earth is revolving around the sun. It is going to have its motion. So from you have seen that all these environment, these surroundings, they are going to be moving. Suppose if you have been observed from the earth, they are going to be at rest. But at somewhere else means if you are going to take another planet, you are being at another planet. Simply watching this, and can you decide it is in rest position or it is in motion? Yes, if it is going to be absorbed from moon, they are going to be in motion. That's what, can you say rest and motion are relative with each other? Very clear. Now you can take that motion. Yeah, this is an electric pole which is having the fixed. We can take that. These parts are being in the rest position. These parts are going to be in motion. Let's see. Yeah. Yes, a person, he used to kick that ball and it changes its position. Very clear. We are going to observe the nature. The bees are flying and the birds are flying. They are going to be in their motion. You can easily find out that their position is going to be changed with respect to the time. We can confirm they are in the rest and motion. Very clear. So undoubtedly we are deciding that the position changes with respect to the time, then it is in motion. Otherwise it is at rest position, no doubt at all. Now let's go for another one. So motion in one dimensional. Let's go for, if you are going to take that motion in one dimension, how you will confirm? Yes, it's restricted to move along one direction. One direction. It's very clear. Now you can take that the motion, yeah, the position changes. If you are going to take that position changes with time. So we can confirm time is a one parameter to decide that position, does it changes. So you can take the object is going to cover that distance in a different time intervals. You can take that from one situation to another one, you can switch on. So for first interval you have taken that t1, second interval t2, and if it is going to cover that equal distance in equal interval of time, then you will confirm that is uniform motion. So equal distance covered in equal intervals of time. That is very clear. Now you can decide that whether the body which is in motion, it is going to be equal distance covered in equal interval of time. It is very clear. Otherwise what happened? It is non-uniform. Let's see that uniform motion. Do you know how you will decide that it is in uniform motion? How you can decide it is non-uniform motion? Yes, you are going to take that one observation. If it covers equal distance in equal interval of times, it is in uniform motion. How it is possible? Generally you can think that the force is going to be uniform. If you are going to act that equal amount of force without changing the mass of the object, then it is in uniform motion. It's very clear. Non-uniform motion, they are going to be observed. Yeah, if you are going to take that gas molecules in the cylinder, they are going to make the collisions, they are going to acted upon the different forces. It is very clear. Now let's go for the terms related to the motion. What are the terms related to the motion? You can take distance, you can take displacement, you can take that time. Obviously we have to take that time. Let's go for distance and speed, displacement and velocity. Just you can take that distance. Why we have to confirm? Without concerning the direction, we can move in any direction. So the actual path you have to take that, you have been reached that A to B. Now you can take that actual path. This is the actual path. That actual path that decides that distance covered. You have to take that. So how you will confirm that displacement? You have to take that. The displacement can be identified. The shortest path, it is going to be, yeah, this is the displacement. So that shortest path between the 2 points or between the 2 points, yes, you can confirm that. For the displacement, you are going to take that in one direction, yeah, the shortest way you are going to take that. You have to follow the direction. So for the distance, there is no direction. But the displacement, it has direction. Very clear, no doubt at all. So if you are going to take the distance, does it gives that speed? Yeah, if you are going to take the displacement, you might be having that velocity, because it depends on velocity. Please take that velocity. It is a one parameter. We can easily identify that. So let's have a look into that matter. Yes, let us take the possibility. The person used to in 1D motion. He was directed to move along the one direction, let us say x axis. We can take that. So easily we will identify that this is a 1D motion. This is a 1D motion. You can confirm that. Now it is very clear. Let's have look into the kinematics. So if you are taking that mechanics, you are going to have that interaction of matter with the force. So obviously you can have the one term force. The mechanical interaction between the force and the matter can produces the displacement. Sometimes without any external force there exists a displacement. You might be having force and without force there exists a motion. So simply you can confirm kinematics is the branch of mechanics which deals the motion of objects without concerning the force. Kinematic, just it has been derived from that Greek literature. The word kinematic, that it is in motion, just you can confirm that. Now let's have a look. Rest and motion. A body doesn't change its position, does not change its position as the time passes with respect to its surroundings. You have to confirm. Yes, with these surroundings it is going to be in, the surroundings are playing important role to decide the body which is in rest or in motion, just you can confirm. So you can confirm the body changes its position as the time increases, as the time is going to increases. If the time changes, the position it is also changes, then you can confirm it is in motion, then it is in motion, right. Now it's very clear. Rest and motion are relative with each other, we have discussed already, right. Motion is the combined property of observer and the body which is going to be being observed. That's what we are going to take, that motion is a combined property of the observer and the body which is being observed. We are going to take that one frame. In that one frame, it is going to be viewed by the observer which is being observed. Yes, it is very clear. What we have taken on the earth, we are going to confirm an object at rest position. It is going to be observed from another planet. It is going to be in motion. That's what we are going to take, that combined property. Now let's take that. We are going to take that examples. For that examples, what we can see. Let's see that now. If you are going to take that, a person who has been in rest position, he was in the rest position, at rest position, very simply you can take that. Yes, it is very clear. You can take that. The train is going to be in motion. Yes, it is going in its direction, but the position of the person is going to be fixed. But the train is going to be, yes, you can take that one. Another person, he was going to be in the train. He used to observe that the particular person who seated in the one place, just you can confirm, he is going to move in one direction actually, but that's called a relativity. If you are going to take that observation from one particular person, if you are going to take that observation from another, like that, from he is going to have the observation the person who has been seated on the bench, he used to move in the one direction. That's called relativity. You can confirm that matter. Yeah. Now you can take that. We can easily understood that matter. Distance. It's very clear. Rat is going to have the fight to search the food. Yeah, it's the food for that rat. You can confirm actually it has to move in a particular. After some time it might have that shortcut. Let's see, displacement. Yeah, you have to take that. Please take that. How it approaches directly to get the food, that is bread. You can confirm. See that? Directly it will reaches. Directly it reaches. So the displacement is the shortest distance, shortest path between the 2 points. So how you will narrate that distance and displacement easily? Yeah, this is the actual path described. This is the shortest distance between the 2 paths. Very simply you will identify that this is A, yeah, AE is the shortest. You can take that is a distance. Yeah, it is very clear. Let's go for another one. Yes, it is defined as the length of actual path followed by the body as it moves. The actual path described by the body which was in motion, that is going to be distance. Now you can take that distance traveled by the body never decreases with time. If you are going to take that in the observation, this is the time and this is the distance, it is going to be like that. Yeah, it's going to be like that. Yes. As the time increases, the distance covered is also increases, but it never decreases. D, it never decreases. D never be negative. We can confirm. Yes, whether the body which is in motion, the distance covered by the body never be negative. It never decreases. Now, if time increases, what happen? It will covers that distance, particular distance. So, if time is going to be increased, the displacement might be changes, but distance is going to be increases. It doesn't take as a negative. Like, let's go for another one. Yeah, the distance traveled by the body can never be negative. It is very, very important point. This is very important. Please identify that. The distance traveled by the body can never be negative. We have to take that. While you are going to take that direction, yeah, the displacement is going to be greater or lesser with respect to the distance. So easily you will find out that, yeah, length of the path is called the distance. We can discuss. So its units are going to be identified meter and centimeter. Now it's going to be identified, it's a scalar quantity, distance. Yeah, it is a scalar quantity. So no relation, it has no direction. So easily you will identify that it's a scalar quantity. If you want to take that direction, you have to move in one particular direction only. So there is no relation regarding to the distance, there is no relation at all with the direction. So it can reach that in any path. Suppose you want to reach the destination A to B, you are going to reach that A to B. Yeah, you can reach in any direction. This is a one direction, this is a one direction, this is also another direction. So this is all about distance. While you are going to take that, yeah, the shortest way, this is the displacement. We can take that. we can confirm this is the displacement. You can reach that A to B directly, it is the displacement, very clear. It is why you are going to take that, it has to move in this direction. So that displacement is a vector quantity which concerned with the direction, right, which follows the direction. This is the shortest distance, simply it is the shortcut to reach that destination A to B. Now let us go for another one. Its dimensional formula is only, distance can be measured in terms of length. It is going to be L. So easily you will identify this. Now you can take another point. The device which is used to measure the distance travelled by the body during its motion, that is odometer. You can take that odometer. Now let us go for another one. Displacement, the shortest distance, it is very clear. Now you will confirm that shortest distance, what we are going to take that, simply if you are going to take that A and B, this is the shortest distance, it follows that direction, right. So if you are going to take that, this is the shortest distance. Suppose if you are going to move in this path, that is, it is not correct. If you are going to take that, it is not correct. So the displacement is the shortest distance. You might be having that shortest path to choose that to reach the destination B. It's very clear. So that you need to take that direction, is very, very important. Follows the direction, it's very, very important. Please take that. Now it's a vector quantity. Why it is a vector quantity? Follows that, follows direction. Yes, we can take that magnitude is equal to the length between the initial position and final position. We have to take that initial position and final position in a particular direction, that gives the magnitude, right. You can take that. Units and dimensional formula, you are going to measure the distance covered by a body during its motion, and the displacement is also measured in terms of same units, whether it is centimeter or meter, and the dimensional formula is going to be same. It's very clear. So dimensional formula are the same, that is L. You can represent distance and displacement. You can take that distance and displacement, both are represented. Yes. So its dimensional formula is m power 0, L power 1, T power 0. This is the displacement and distance. It's very clear. We can identify that. This is the. Now let's go for another point. Yes, is it clear? The distance and displacement. Now you are going to take the different problems and different cases. An object is going to be execute that motion. You can see that. Yes, it's going to be circular motion. Now you are going to take that, its direction of velocity is identified that. Now in this, it has been started and it is going to be it's going to be identified. Now, do you know, or it's a radius, let us assume. In this situation, how you will calculate the distance covered displacement? You can take that, yeah, displacement is 0, It has been started from this point and it has been reached that same point. That is, you can confirm that during the motion it covers the distance, but while you are talking about the displacement, it doesn't changes its position. Simply, it has been reached that same position. The particle executes that one cycle. It has been executed 3 cycles, 4 cycles, complete cycles. Whether it is half, we will find out that displacement, that is equal to 2r. Here the displacement is 0. What about the distance? Distance covered. Yeah, it has been moved in this direction. Yes, you can indicate. Yes, it's very clear. Distance covered, it is identified. If r is the radius, it's going to be 2 pi r. Very clear. Now, if you are taking that particle is going to reach this. Yeah. Yes, this is A, this is O and B. It has been, yes, here it has been executed that half cycle, just you can take that. In this case, the displacement 0 or something else, just you have to take, yeah, you have to take that the shortest distance. It's going to be, yeah, this is going to be r and r. So displacement is equal to, you can confirm displacement is equal to r plus r. Easily you will find out that is 2r. And the distance covered, how you will find out distance covered? That is pi r, 2 pi r by 2. We will take that. Now let's have a look. Yes, you can take. It's very clear what we are having the observation. Please have a look. Displacement is 0 in the first case. Distance covered is 2 pi r. In this case, the displacement is not equal to 0. Now you can take that. Yeah, let's have a look. If the particle starting from point A and moves along the circular path and reaches the same point, that is, the initial and final position are going to be coincide at one point. That is, it has been reached after the displacement, it reaches the same position. So you can confirm the displacement is 0. Now you can take that distance is equal to circumference of the circle. Very clear. It can be identified 2 pi r and the displacement is 0. Now let's go for another one. Here initial and final point, why it is going to be 0? Why it is going to be 0? Just we have to observe that because of its initial and final point is same. Initial and final point both are going to be same. Then you may not find out the displacement. It is going to be 0. Right. Now let's go for another one. Yeah, in this case what we are going to identify this. Yes, if the particle travels along the along a semicircular path, from A to B, that is of, you can take that semicircular path. Yes, what is that distance? If you are going to take that, yeah, it is going to be, this is the distance. Yes, what about that displacement? You can take that, yeah, displacement. How you will measure that? That is, displacement is equal to this r plus r, AB is equal to r plus r, that is equal to displacement. Simply you will confirm that the shortest distance between these 2 points is going to be identified as a displacement. It is very clear, displacement AO plus AB, it is going to be 2r, very clear. In this case, displacement has been identified as 2r and the distance covered by the particle is going to be 2 pi r by 2. Right. Now let us go for direction of the displacement is from A to B. It is going to be followed in this direction. Yeah, it has been followed. It is going to be A to B. You can confirm. Now, while you are going to talk about that distance and displacement which follows the direction displacement, it is very clear. Now let us go for another case. It is very clear about that distance and displacement. Now let us have another case. Yes, let us take that. Yeah, we are going to take, this is a case. Now very clear, if a particle travels from point A to B along a circumference circle as shown in the figure, right. Now, so we are going to talk about that. Here we will take that yes, you can take, yeah, center. Now you will, very clear, while you are going to describe this one, this diagram, you can easily take that. Yeah. Yes, you have taken that. This is AB. Yes. So AB is the shortest distance, just you can confirm that, that gives the displacement if you are directed to move along this path. Yes. So easily you will find out that r is equal to radius, r is equal to radius of circle. You can take that and you will confirm that easily. You will take that circumference, yeah, 2 pi r, that gives the circumference, very clear. It covers the 1/4, it covers the 1/4, it covers the 1/4 of the journey, 1/4 of the total journey. In order to complete one cycle, you have to take that 2 pi r. But what about that 1/4? Yeah, you have to take that. Very clear. That is, you can take that distance. Yeah, will. Now you can take that AB is equal to displacement. AB is equal to displacement. Here you can talk that distance covered. that is equal to 2 pi r into 1 by 4. Just you have to take that pi r by 2. Very clear, because during its journey it has taken that 1/4 of the revolution. It's very clear. Now AB is the displacement. How you will find out AB? Yeah, it's equal to root of r square plus r square. We can easily find out that. That is 2r square. That is root 2r. Very clear. Yes, from these two topics you can understood in a better way. While you are solving the problems related to the displacement and distance, easily you will find out that, yeah, AB is equal to root 2r. How it has been obtained? Based on Pythagoras theorem. You can take that, yeah, AB is equal to, yes, this is from figure. You will find out that 1/4 revolution. It has been covered 1/4. It has been covered half of the distance. So complete path. We have taken the three cases, first case and second case and third case. In which of the three cases displacement 0 when it completes one cycle? Yeah, it will complete one rotation, let us assume. The initial and final position is going to be same. Here it is going to be following A to B. It has direction A to B. Here initial and final position, they are not going to be same. So they are going to be different. So displacement is not equal to 0 in that case. It is very clear. Now if you are going to take that another case, you can take this case. You will take, this is the R radius, or we can take that R, the particle which has been started and it has been completed. Yes, here this is the B. So in this case we can understood. What about that distance covered? Distance covered. Yeah, how you will find out that displacement? It's very clear. How you can calculate easily? Yeah, you can calculate the displacement, and distance covered is going to be, yes, 3 by 4 into 2 pi r, and displacement is going to be identified, that is AB is equal to, yeah, it is also r. So this is root of r square plus r square, simply root of r square plus r square, that is 2 root r. Just you will, yeah, easily you will identify that root of 2 r square, that is root 2 r. Very clear. Please have a look. We can describe that the motion of a particle, whether it has been completed 1/4 cycle, half of the cycle, complete cycle. In all the different cases we can easily find out that distance and displacement. So they are going to give the different kinds of the problems based on these two topics, distance and displacement. Yeah, whether it is going to be having that number of cycles, 4, 5, 6, 7, it has been the completed cycles, then you can easily understood the initial and final positions both are going to be same. It has reached that initial position after the displacement. Just you can confirm. In that case the displacement is going to be 0. It is very clear. Yes, if the particle travels from A to B along the circumference of the circle as shown in the figure, now we can easily find out that. Right, let us go for another one. Yes, can you take that distance and displacement, which is greater, which is smaller, even though it will having that same time during its journey, they are having that same time duration. If you are going to confirm that, which can differentiate the path which has been described, the shortest path or any other independent path to reach the distance A to B. So, which is greater, which is not going to be 0 and which is negative, which is positive, and we can discuss all these things. Yeah, whenever the particle is traveling in a straight line in the same direction, yes, it is very clear. You can take that this is A, this is B. Yeah, you have to confirm its direction. Let us about 1D motion. Yeah, it is going to be in the straight line path. It is going to be in the straight line path. Now, you can easily identify that the distance and displacement both are same. Whether they are going to be described in the same path, you can easily identify that. It is very clear. Now, you can identify that distance is equal to displacement. It is very clear. Now, you can confirm what happened if you are there, they are going to having the different path to reach the destination. Let us assume B is the destination. He has to reach that B. In that cases, so it is going to be like that, right. You can confirm, that is, this is the displacement and D. In this case, right, distance is greater than displacement, because the path which can creates the difference, this is a one path, this is the first one and this is the second one. In the first case, D and small d and capital D, what we have taken, displacement and distance both are equal. In the second case, they are going to be like that. It is very clear. So, let us have that direction. Suddenly it will changes the direction. What happened? Displacement is going to be less. It will reverse. But distance is, yes, you will take that distance is greater than displacement. You can confirm that. You can confirm displacement. Yeah. Yes, you can take that in a straight line. It reverses the direction, then distance. So, it will comes and it is going to change and it will changes its direction. This is the A and B. You are going to take that. So, in this case, distance, initially it is in the forward direction. Yes, after that it will changes its direction. It is nothing but displacement. You can, have you seen it is following in this direction? After some time it is going to change its direction. It is reversed, let us assume. In that case, the distance travelled by the body is going to be more than that displacement. You have to confirm. This is the displacement. So, in this case, distance and displacement are different. We are having the different cases. While you are solving the problems, you need to take that. You need to apply the concept to solve the problems in a better way. So, all of you, thank you very much. Have the nice day and convey to all the people regarding to these lectures and make them happy. Yeah, while you are informing to all other people as being your friends and all some others. Yeah, please inform, let them to be happy and convey to all the people regarding to the app master and these well crafted animated videos and modern teaching aids, what we are practicing to deliver the concept in a better way.